In this series of lessons, we're having a look at how to solve simultaneous equations, and we've discovered that they can be solved by drawing them accurately on the same set of xy axes and finding where they intersect, or we can use one of two algebraic methods to solve them. We've already had a look at method 1, substitution, and in this video we're going to have a look at the final method called elimination. The key idea behind the elimination method is to eliminate or get rid of one of the pronumerals by adding or subtracting the two equations. Now this means we need to make sure that the coefficients of one of the pronumerals are identical. They can have the opposite signs, but the number value must be the same. And so the steps are as follows. Firstly, we make sure that the two coefficients of one pronumeral are the same, and this may require multiplying or dividing one or perhaps both of the equations by a number. The second step is to eliminate the pronumeral by adding or subtracting the equations. Then we solve the new equation and substitute this value into one of the equations to find the value of the second pronumeral. Now once again, you may like to pause the video here and get these notes down, but we're going to now have a look at these steps and we'll understand them as we actually do a few examples. In this question we need to solve two simultaneous equations, and we'll set them out like this. Y is equal to x plus 4, and we'll call this equation 1, and we've got y is equal to minus 2x plus 7. We'll call this equation 2. Now you'll notice that y has a coefficient of 1, and so does the y down here. So if we actually subtract equation 1 and equation 2, we'll actually get rid of the value of y, because y minus y is 0. So that's exactly what we're going to do. We're going to take equation 1 and we're going to subtract equation 2 from it. So we get 4 take away 7, which is minus 3, and x minus 2x, so that's plus 2x, so it's x plus 2x, that's 3x, equals 0, because y take away y is 0. And when we rearrange this, we get 3x on this side is equal to 3, and we can get x is equal to 1. So we've eliminated y, and now we have the value of x. So we'll call this number 3. And we're going to substitute 3, this value of x, into one of the other equations. And so we'll put it into number 1 because it just looks easier. So wherever we see an x, we're going to replace it with 1. So we have y equal to, there's an x, so we replace it with 1, and we've got plus 4. So we know that y is equal to 5. Now we've finally got our solution, because x is equal, and we can put there therefore, let's say, therefore x is equal to 1 and y is equal to 5. Or if we wish to write it as coordinates where the lines intersect, we would have them as the point 1, 5 on the number plane. Let's try this example here. We've got 2x plus 3y equal to 14, and we've got 2x minus y equal to 6. Now in this case we've got 2x and 2x with the same coefficients. So once again, if we subtract these equations, we're going to eliminate 2x, and we'll have at least one of our solutions once we solve the remaining equation. So what we'll say is we're going to call this equation 1, this one equation 2, and we're going to take number 1 and subtract number 2 from it. So 14 take away 6 gives us 8. 3y take away minus y, that's 3y plus y, gives us 4y. And we eliminate here because we've got 2x take away 2x. So then we solve for y and we get y is equal to 2. So there's one of our solutions. We'll call this number 3 and we'll substitute 3 into one of the other equations. And I think probably the easier one would be number 2. Now it doesn't matter which one you substitute into, you'll still get the correct answer if you do it carefully. So wherever I see a y, I'm going to replace it with 2 in this particular equation. So we've got 2x minus, now y is 2, equals 6. So solving this, we get 2x is equal to 8 and x is equal to 4. So our solution is that x is equal to 4 and y is equal to 2, or in ordered pairs we've got 4 and 2 as our solution. Let's have a look at how we'll solve these two simultaneous equations. We'll write the first one down, 2x minus 3y equal to 2. We'll call that number 1. We'll look at 5x plus 2y equal to 5, and we'll call that number 2. And we'll notice that 5 and 2 are not the same and 3 and 2 are not the same, so we've got to do something to make these coefficients the same, at least one pair of coefficients the same. And this is where we need the idea of the lowest common multiple. Now I'm going to select the lowest common multiple of 3 and 2. I'm going to change these two numbers to be the same. And the lowest common multiple of 3 and 2 is 6. So if I multiply equation 1 with 2, that will change this into a 6. 2 2's, 2 3's and 2 2's. And if I multiply equation 2 with 3, then 2 3's are 6. It's going to make these the same. So let's see what we get once we do this. So let's multiply equation 1 with 2. I get 4x minus, now 2 3's are 6y, equal 2 2's are 4. We'll call this equation 3. Now they're equivalent equations, so we'll create an equivalent equation here by multiplying it with 3. So 3 5's are 15x plus, now we've got 3 2's, 2 3's are 6y, is equal to 3 5's are 15. And that's, we'll call equation 4. And now you'll notice that our coefficients are the same, and if I add them together, I'm actually going to eliminate the 6. So what we're going to do is we're going to have 3 and we're going to add it to 4 and get our solution. So 15 and 4 is 19. Now these eliminate because it's minus 6 plus 6y, they disappear, and 4x plus 15x is 19x. So x is equal to 1. So the next thing we do is we substitute x equal to 1. We'll actually call this number 5. We'll substitute 5 into, let's say, equation number 1. Now it doesn't matter, once again, which one we substitute into, we will get the same answer. So wherever I see an x, I'm going to replace it with a 1. So I get 2 times 1 is 1, minus 3y equals to 2. So I'm just going to move this up slightly so we can have a little more space. Now when I solve this, I get minus 3y equal to 2 take 2, which is 0. So y, in fact, is 0. So our solution to this equation is x is equal to 1 and y is equal to 0. The ordered pairs being 1 and 0.